AP Cram, Calculus AP, Section 1, Exam Review. Question 6. Evaluate a limit. What is the limit as h approaches 0 of 8 times 1/2 plus h to the 8th power minus 8 times 1/2 to the 8th power divided by h? Is it A, 0, B, 1/2, C, 1, D, the limit does not exist, or E, it cannot be determined from the information given? Okay, so in evaluating what the limit is as h approaches 0, the first thing that we're going to do is simplify the expression by expanding it. And someone asked that I use x in this question instead of h because the variable x is more familiar to a lot of people, but it could be any variable. It could be a, b, c, d, x, y, z. All right. So yeah, we're gonna expand it. And so in expanding this expression, the first portion that we're going to simplify is this portion. And we're going to expand it by using the binomial expansion theorem, which is this theorem right here. And it's good to be familiar with it in case you don't know. It just says a plus b. In this case, our a is x, and our b is 1/2 to the n. In this case, our n is the number 8, equals the summation from k equals 0. So starting at the number 0 all the way to n, again, which is 8, of n choose k. And this is just combinatorics mathematics that you might have seen in statistics, or you may not have seen. It looks really complicated, but it's really easy. It's just like a lot of steps. Times a to the n minus k, that would be 8 minus whatever value of k. So it could be like starting at 8 minus 8 all the way down to 0, times b, and b again is 1/2 to the k. So that could be starting at, 8 or 0 or 7. So k again takes on any value between 0 all the way up until n, which is 8. And just in case you're wondering what n choose k is in this expression, n is going to represent n factorial in the numerator, and k represents k factorial in the denominator multiplied by n minus k. All right, so if the value were 8, it would be, well, the value is 8 for n. It's going to be 8 factorial, and let's say we're on the instance of k where it's 3. It would be 3 factorial multiplied by n minus k. So 8 minus 3 would be 5 factorial. N minus k factorial, that is, okay? All right. All right, so this is how the binomial expansion theorem starts to look when applied to this exponent, x plus 1/2 raised to the 8th power. All right, so we have our beginning summation sign. Again, we have n choose k, 8 choose k, times 1/2 to the 8 minus k power, okay? Times x minus k. And remember, well, here we're choosing 1/2 as our a, and x to the k as our b, okay? So it could have been in either direction. It doesn't really, you could choose x as b, x is a, and k 1/2 to the 8th power is b. It doesn't really matter. It kind of all works out the same. So we have 8 choose 0 times 1/2 raised to the 8th power times, so that's x minus 0, times x to the 0 power, okay? That's why you don't see the 0 here, because anything raised to the 0 power is just going to be 1. Then we have 8 choose 1. So that's going to be times 1/2 to the 7 power times x to the first, and 1/2 to the 7 power is just 8 minus 1. So we have 8 times 2, 8 choose 2 times 1/2 to the 6th power, and 1/2 to the 6th power represents 8 minus 2 times x raised to the 2 power, so that's just raised to the combinatoric number in the bottom, okay? This is another way of doing it instead of like actually, looking for k. Well, yeah, you look for k right here. And I don't feel like telling you the rest because it's pretty redundant, so you get the point. You should definitely pause and write this out yourself so that your neurons can get the feel for carrying out something this tedious. It's not a difficult problem. It just takes a lot of organization and writing, but it's definitely doable within, I'd say, less than 5 minutes. All right, so you end up all the way with, 8, 8. So then you're going to have 8 raised to the 8 minus 8 power, which is 0 power, times x to the 8th power. And so when you solve all the factorials, all the combinatorics factorials, this is what you end up with. As an example, let's evaluate the combinatorics factorial for the first expression. So we'll go all the way up to this 8 choose 0. So 8 factorial times 0 factorial. I'm not going to write it out because this is taking, well, yeah, I will. Times 8 minus 0 factorial, which is just going to be 8 factorial. So this nicely simplifies to 1. Okay, so you would evaluate all of these expressions, and they turn out to be the numerical coefficients. Okay, and remember, all we're doing here is evaluating this. We haven't even applied the 8 yet that you have to multiply by, okay? Okay, so now we're going to plug the expanded expression back into the overall problem. And now we're going to shift gears and evaluate this over here. All right, so we can simplify 1 over 2 to the 8th power by using the power rule that p divided by q raised to the n is equivalent to p to the nth power over q to the nth power. All right, so the first thing that we can do is evaluate 1 to the 8th power, and we know that's just going to be 1 times 1 times 1 times 1, hence 1. So to compute 2 to the 8th power, what we're going to have to do is repeated squaring. So that is, you look at this and you break it down into exponents, okay? So you can extract an exponent of 2 and you wind up with 2 to the 4th power, extract another exponent of 2. So we're going to extract an exponent of 2 out of this, and we wind up with 2 to the 2nd power times raised to the power of 2. Okay, so we know that when we raise exponents to each other, we're actually just multiplying them. So if we were to multiply the exponent 2 times 2, that would give us 2 to the 4th and 2 to the 8th, hence giving us the original expression. Okay, so what's 2 to the 2nd power? It's going to be 4. And then what's 4 raised to the second power. That's going to be 16. And 16 squared, if you haven't memorized it, it's going to be 256. And again, if you do a lot of problems, you'll encounter a lot of 16 squareds, and you'll just automatically pick up on the fact that it's 256. I think I said 26 before, I can't remember. But if you don't know that offhand, you can do some, simple multiplication. So 6 times 6 is going to be 36. Carry the 3. 6 times 1 is 1 plus 3, that's going to give you the 9. Hold the place value to multiply the 1 or the 10 in the bottom 16 by everything in the top. So you're going to get 1 times 6 is going to give you 6. And 1 times 1 is going to give you 1. Now you just add both terms. And 6 plus 0 is 6. 9 plus 6 is 15. You write the 5. Carry the 1. 1 plus 1 is going to give you 2. Okay? Alright, so what we can now do is plug 256 back into the equation. And the next thing that we're going to do is simplify the fraction 8 over 256. So 8 divided by 8 in the numerator and divide by 8 in the denominator. And if you're wondering where this 8 came from in the first place, it was once out here, so we just kind of combined it with 1 over 256, which was originally 1 to the 8th power over 2 to the 8th power. So for those of you who encounter this problem all the time, 256 divided by 8, you'll automatically remember that the answer is 32, but just in case you're not familiar and you don't remember, let's just do some long division. So 8 doesn't go into 2, but it does go into 25, and it does so 3 times, so you place the 3 over your 25. Okay, so 3 times 8 is going to give you 24. You write it here, and the rule is you subtract 24 from 25. The remainder is going to be 1. So now you bring down the 6. 8 goes into 16. Oh, sorry for that. 8 goes into 16 evenly twice, so you write it above. Okay, and then you bring down the 16, the rule is you subtract it, and the remainder is 0. So 8 goes into 256 32 times. You can express that here. Okay, and again, you're going to distribute this 8 now over everything. Multiply, and then when you get to the sections where you have fractions, you simplify. Here, the 8s would cancel out. Here, you would get like a 2 times 7. Yeah, so you get the point. I'm not going to go through this. I think you get the point by now. So you basically distribute the 8 and cancel and simplify wherever you can, and you'll wind up with this expression. Now what you can do is you can combine like terms, okay? So here goes like one set of like terms that you can combine. After combining like terms, the 1 over 32 minus the other 1 over 32, they're going to cancel out. So we've gotten rid of them. Now what we want to do is express this whole equation as a sum of fractions. So here we go. And you'll notice that all the x's in the denominator basically cancel out. All right, I'm not gonna like slash every single one out, but and then where there are higher order exponents, they get reduced by 1. Okay, so that I'm pretty sure you can figure out on your own. All right, now what you can do at this point is substitute 0 everywhere you have an x, or an h rather. Remember, I just used x because that's the variable that most people are familiar with. but I'm going to switch back over to h to express the final solution. And so the limit as h approaches 0 is going to be 1/2. All right, but it's not readily apparent in this form. That's why you have to do all these things. And a lot of these steps can be condensed. I'm just doing this for people who are not familiar with the tedious multiplication steps and adding steps and reducing steps. And you'll get more of a knack for how to algebraically manipulate expressions that deal with limits as you just get more practice doing more problems, okay? Again, the correct answer is B, 1/2.